Question number 28. A unit step voltage 2 into u of t minus theta is applied in a series RC circuit where R equal to 2 ohms and C equal to 1 farad. Assuming zero initial conditions, find I of t. So what he is asking is, he has given an RC circuit, he has given input voltage, he is asking output. Simply input is given, RC circuit is, for that RC circuit input is applied and he is expecting output at the capacitor. So assuming zero initial condition, so it is not any transient and all those things are not involved. So let us find this very simple question, and it is directly a question based on a Laplace transforms. Okay, you can solve this easily. Fine. Now what I have taken is, I have simply taken RC circuit. R is there, C is there. It's nothing a big name. RC means a resistor and C is a capacitor. That's it. And input I have taken it as VI. VI what he has given, 2 into u of t minus theta. Same thing I have taken. Okay. Then R is given as 2 ohms. C is given as 1 farad. I have taken the same. Fine. Now see, I have indicated with an orange color, which indicates the Laplace transform of each of the component present in this circuit. Okay, this here I am taking the output. Okay, here I am taking the output. Fine. R is given 2 ohms and C is given 1 farad. Fine. Now sorry. Okay, now let us see the Laplace transform of each component. 2 into u of t minus theta. See, 2 you write as it is. I'm teaching Laplace transform, I think you should know already. U of t means unit step function as a Laplace transform 1 by s. I wrote 2 by s, but this is a time delayed signal, so you will get e power minus theta of s. Just refer Laplace transform signals and system pairs, you will get the Laplace transform of it. It's very simple. Being at this stage, you should be able to know. If you don't know, I'll be starting a signals and systems lectures in the next month for the gate preparation, so you can review that. Fine. So R is given 2 ohms, then capacitor is given 1 farad. Now what he is simply asking is, what is a current? That is very simple. Current is nothing but I of s. I am completely doing in terms of Laplace. I of s is nothing but input voltage by total impedance. Sorry, he is not asking output voltage, he is simply asking current. I'm sorry, he is simply asking current, so no need of output voltage. Okay, so he is simply asking what is the current. Okay, fine. Now I of s is nothing but V of s by Z of s. V of s is already known, 2 into e power minus theta by s by R plus 1 by sc. Laplace transform of capacitor is 1 by sc. Laplace transform of resistor is R itself. So let me substitute R and C value. R is 2, C is 1. So I substituted, then I got this step. I think you understood up to this. Then finally I simplified, I got this. Again I cancelled s and s. I'll not teach this simplification part, you should be able to understand, right? So this you'll get, finally you'll get this. Then what I'll explain is, I'll explain simply how to find inverse Laplace transform of this. Okay, so I of s is given, but the options are in terms of, not in terms of I of s, they are in time domain. So we have used only Laplace as a tool. So solve this question and finally throw that Laplace transform somewhere. Finally we'll get a time domain expression. So how to find the Laplace transform of this? I'll explain you clearly. This is the answer we got for the current. Now it may look complex for you. You split it into two parts. Assume that there is only 1 by s plus 1 by 2. If this is there, then the inverse Laplace transform you will find easily, right? 1 by s plus a. 1 by s plus a as a Laplace transform of e power minus at u of t, right? Similar way, 1 by s plus 1 by 2 half is having Laplace transform e power minus half t ut. This is understood everywhere. Now extra term will come. This is the for first term. Second term, this extra term now I'm inserting e power minus theta. Step by step I'm doing. If there is a time delay in the frequency, then it is compensated in the time domain. So if it is minus theta, just subtract minus theta from time. Okay, that is a property. Again you have delay in the frequency signal, delay in the time domain signal, all those things you have studied. If not, we'll study in the next month. So this is the final answer. So e power minus 0.5 theta t minus theta into u of theta minus t amperes is the right choice. So the right choice you can see, yeah, where is that? Yeah, option C is the right choice, correct? Yeah, e power minus 0.5 is there. Here no 0.5 e power, so this cannot be. Here minus 2 theta, this cannot be, this cannot be. So the right choice is option C. And you can actually eliminate two options, A and B, because if the input is delayed by t minus theta, output also will delay by t minus theta if it is an LTI system. RC circuit, here it will obey, it will act as an LTI system. For an LTI system, whatever applies for the input, output will also do the same thing. Input is delayed by theta, t minus theta is the input delayed, right? Output will also have a term, time will be delayed by t minus theta. So easily you can eliminate option A and B, because ISRO you need to eliminate a lot of things. Only thing you need to check whether this 0.5 will come or not. Due to the presence of this 2, this 0.5 has arrived. Like that you can do the calculations. Okay, fine. So this 0.5 might have come from this 2 or this 2. Okay, you need to check by doing this, all those things. Okay, fine. In this way you will find the Laplace of the given circuit. This is an easy question. Try to do it on your own and try to, I'm not giving extension for this question, especially because you need to read all the Laplace transform and its properties. Okay, that is my intention. Please try to learn the Laplace transform properties and all the standard results. I'm not giving here because every textbook there will be a Laplace transform, right? So open it and please, as soon as you finish this video, just do the extension for me. Okay, I hope you will do for me. Okay, thank you. So, and also if you have any doubts, please comment in the comment box, and you just subscribe this video, subscribe this channel for getting more updates. Thank you.